Today we are going to see the significant figures and different rules to find out the significant figure in the measurement or in the numbers, and there are different rules containing 0 and also addition, subtraction, multiplication, division, and based on all these rules we can calculate the number of significant figures in the given result or in the measurement. So today's topic is now significant figures. We are going to see what is significant figures and what are the different rules to determine significant figures in the number. So the measurement involving the counting only the chairs, table or banana like that can be known accurately, but many scientific measurements involving some measuring devices cannot be known accurately. Therefore, the accuracy of any such measurement depends upon two factors. Number one is the accuracy of the measuring device used, and second is the skill of the operator. So these are the two important things which measure the accuracy of the measurement device. And here it is necessary to indicate in the reported result that how to measure accurately. It has been measured, and for example, suppose the mass of an object has been determined and it is to be a 14.5678 gram. This means that the actual mass of the object is 14.5678 plus minus 0.0001 gram. That is, it lies between 14.5677 and 14.5679. Therefore, in the express mass, the first 5 digits are certain, but last involve uncertainty of plus minus 1. All measured quantity are reported in such way that only the last digit is uncertain, and generally the plus minus 1. And therefore we conclude that measurement of the various variables such as weight, volume, density or the pressure, temperature, etc. can be only precise and not exact, since every measuring scale has its own precision. The uncertainty in the measurement can be expressed in terms of certain figures which are often known as significant figures. Therefore, in order to understand the implication of the term significant figure, let us assume that we want to measure the volume of the liquid with a graduated cylinder. Then it is observed that volume of the liquid is more than 3 ml and less than 4 ml. In that case, it lies between 3 and 4 ml. We can guess that it is about 0.4 ml, between 3 and 4 marks. Therefore, it may be reported as 3.4 ml. In this case, 3 is a certain digit and 4 is an uncertain digit. Therefore, number 3.4 has two significant figures. So in this way we can calculate the number of significant figures in the number, and therefore we conclude that number of significant figures in any number depends upon the precision of the scale employed for the purpose, and better the precision of the measuring scale, lesser will be the uncertainty in the measurement. So in this way this is significant figures, and we are going to see what are the rules to report number of significant figures. So here the rule number 1 is that so 4 basic rules are there to counting the number of significant figures. So rule number 1 is all digits are significant except 0 given at the beginning of the number. For example, here, so again I am repeating that all digits are significant except the 0 given at the beginning of the number. For example, so here 0 is there, 0.231. So in this number there are 3 significant figures. As per the rule number 1, 0 present in the beginning of the number is not significant. Therefore, this number has 3 significant figures. In this case, 0.045. This number has 2 significant figures, and third one is 0.005. So it has 1 significant figure. 0 is not significant when it is present in the beginning of the number. Second rule says that a 0 becomes significant in case if it comes in between the two non-zero numbers. For example, here 2.05 this number has 3 significant figures because 0 is present between 2 and 5. So this 0 is significant. When the 0 comes in between the two non-zero number, then in that case the 0 becomes significant. So according to this rule number 2, so there are 3 significant figures in the first example. In this case 6.204 has, this number has 4 significant figures, and in the third 4.0032, in that case there are 5 significant figures. Okay, so according to the rule number 2, the 0 becomes significant when it comes in between two non-zero numbers. And rule number 3 says that all 0 placed to the right of the number are significant. For example, okay, third is all 0 placed to the right of the number are significant. For example, here 3.53.0 has 4 significant, all 0 are significant placed to the right of the number. Here 323.00 has 5 significant figures. Third example is 363.000 has 6 significant figures. So all 0 present to the right of the number are significant. And rule number 4, in the exponential notation, the numerical part represents the number of significant figure. For example, every number is represented as, according to the scientific or exponential notation, it is represented n into 10 to the power n, n into 10 to the power n. And this is the scientific notation. In this case, capital N is the number with single non-zero digit on the left of the decimal point, and small n is the integer, and therefore in the exponential notation are also known as scientific notation. These are quite useful in writing very small as well as very large mathematical number. For example, here number 0.00064 can be expressed as 6.4 into 10 to the power minus 6 in this term, in terms of scientific notation. The number of significant figure in this number is 2. Similarly, number of significant figure in the Avogadro number, that is Avogadro number is 6.023 into 10 to the power 23 is 4. So in case of Avogadro number, the number of significant figures are 4. So in this way we can express large number, large or small, in a scientific notation. So exponential notation is also known as scientific notation. Now again, there are certain two important rules are there for calculating the significant figure. So rule 1 is that, and in this rule number 1, rule number 1 says that the certain rules are there. So rule number 1, the number of significant figure in the mathematical treatment are obtained by the two rules are there. So rule number 1 says that when addition or subtraction is to be carried out in the number having different precision, the final result should be reported up to the same number of decimal places as are present in the number having the least number of decimal places. So this is the rule number 1. It is when addition or subtraction is to be carried out in the number having different precision, then the final result should be reported up to the same number of decimal places, up to the same number of decimal places. This is important, as are present in the number having the least number of decimal places. And now we can illustrate this rule and a number, addition of number. We are taking both addition and subtraction. So first, A is the addition of number. So in case of addition of number, suppose we take 3 number for addition. One is a 10.23 and second is 2.1 and third is 0.212. The number having least decimal place is 2.1. So in this case, and therefore final result should also be reported to up to the 1 decimal place. So next slide shows the addition of the number. And so here we have 10.23 plus 2.1 plus 2.212. So in this case 4 significant figure 2 and here 3. So least out of these 3 number, this number having only 1 decimal place. Here we have to see 0.1 decimal place here, here 2 decimal places, here 3 decimal places. So least is 1, and therefore final result should also be reported up to the 1 decimal place. So here after addition we get this result 12.542. Answer should be reported up to 1 decimal place. So correct answer is now 12.5. Okay, 12.5. After minimum here 1 decimal place. So here final result should also be reported up to 1 minimum decimal place as given in the numbers. So 12.5 is the correct answer. Another example of addition of number, this number is added with this 3.201.01. In this case 2 decimal, in this case 3, in this case 4 decimal places are there. So final result also we have to report. So out of these 3 number, this number has 2 decimal places. So after adding we get this answer, and final result should be reported up to, so final result should also be reported up to 2 decimal places. Therefore correct answer is 45.35, only 2 decimal places. So this is in case of addition and the subtraction. And in case of B, subtraction of number. So subtraction of the number is also carried out in the same way as we did in case of the addition. Okay, so in case of the subtraction, if you take these two number, 25.4630 minus 24.21, final answer is here. So out of these two, here are the 2 decimal places, here are the 4 decimal places. So final result should be reported up to 2 decimal places. So here this is the answer, and final correct answer is now 1.25. In the similar way, another example, this is the number minus this 5.204, and this number has 3 decimal places. So final result, this result should be reported up to 3 decimal places, and therefore correct answer is 1.191. So in this way, in case of addition and subtraction, final after addition and after subtraction, the final result should be reported up to the minimum number of decimal places present in the number. So this is in case of addition and subtraction. Now rule number 2 says that in case of multiplication and division, the final result should be reported up to the same number of significant figure as are present in the least precise term. Now slight changes here. There in first rule we have to report result up to minimum number of decimal places, but now in the rule number 2, in case of multiplication and division, we have to report the final result up to the minimum number of significant figure as are present in the number. So we are going to see the multiplication of numbers. See now here, if we multiply 2.2120 with the 0.011, the value comes out to be 0.024332, but according to the rule must be reported with the 2 significant figures. Now here this number is multiplied with this, and this number has 2 significant figures because 0 is not significant, only 1 1. This is the having this number having 2 significant figure, and after multiplying we get this answer. So final result, this answer should be reported to the 2 significant figures. So final result is a 0.024. 0.024. 24 is the only contain 2 significant figures. In this way, similarly also in case of division and division of numbers, and if we divide the number, also in the similar way we have to report up to the minimum number of decimal places. If we divide 8.2433 and by 4.67, then the result comes out to be 1.76516. But according to the rule, it must be reported up to 3 significant figure as shown here. Again, addition, here multiplication, divisions are similar. So this is number and this is divided. Okay, not addition here. Divide this number by 4.67. This number has 3 significant figure. So after dividing, we answer is this one. So 1.6517 answer should be reported up to 3 decimal places. So correct answer is 1.76. In this way, in case of multiplication and division, we have to report the result in a number of significant figure as a present minimum in the numbers. So based on all these addition, subtraction, multiplication, division and rules of this, here there are some numerical problem. So here we are going to see some numerical problem based on this. So number 1, example 1 here, state the number of significant figure in the following numbers. So these 4 numbers are given here. So in case of first, this is expressed in given in a scientific notation. Therefore in this case number of has a written according to scientific notation, and as we know how to write scientific notation, n to 10 to the power n. In that case this number is the number of significant figures. So therefore in this case the number of significant figures are 4. 1 2 3 4. We are not counting this. Okay, so number of significant figures in case of this is a 4. In case of second, 0 is not significant, therefore 5 6 7, only 3. So in this case number of significant figures are 3. And in case of third, here 653, so only 3 are there, so there are 3 significant figures. In this case again there are 3 significant figures. In this way we can find out the number of significant figures. This is example 1. Now in case of example 2 and 3, in case of 2, the population of Nagpur is 1604000 according to the latest census, and express the same in terms of scientific notation and calculate the number of significant figures. So in this case we can express this number in the scientific notation in this way: 1.604 into 10 to the power 6, and therefore in this case number of significant figures are 4. So in this way we can calculate number of significant figure. In case of this another example, what is the difference between 5.0 and 5.000 gram? So 5.0 and 5.00 gram. So actually they look like equivalent, but scientifically they are different, and therefore in this case there are 2 significant figures, and in this case there are 3 significant figures. So answer is this is the answer. Okay, and in the next example number 4, again the problem is how many significant figures are there in each of the following number. These are the numbers given, and we have to find out number of significant figures. So in this case there are 4 significant figures. In this case also there are 4 significant figures because this scientific notation. In this case 0 is placed on the right hand side, therefore this can be written in this way: 8 into 10 to the power 3, therefore number of significant figure is 1. And in case of 4, the number of significant figures are 2 because 0 is not significant. In this case, in the case of 5, if you do the addition, and here decimal place is only 1 decimal place, so final after addition the result is to be shown here, and the final result should be reported to the 18.9, only up to 1 decimal place. And in case of last example, the product multiplication, and here are the 2 significant figures, here are 4, so we have to report the result to 2 significant figures. So answer is coming here, that is 14, and has 2 significant figures. So minimum, so we have to find out how many significant figures. So in this product there is no need to multiply, but what is now final result should be reported, but here the number of significant figures are 2. In this way we can calculate the significant figures. In another example, express the following to the 4 significant figures. These are the numbers given, and we have to report up to 4 significant figures. So in case of first, we can write 6.4537. So 4 means up to 3. So also round off it. 6.454. We have, this is a round off, we have and 4 significant figures are here. In this case 48.38, 4 significant figures, because 0.250 is less than 5, and here this can be represented 7.000 into 10 to the power 3, therefore number of significant figures are 4. We have to report up to 4, so in this way we can report 7.000 into 10 to the power 3. In case of this number, we have to report 2.660 because greater than value, so and 10 to the power 3. This can be reported into 0.00004687. So this is the expression into 4 significant figures. And another example is express the following number up to 3 significant figures. This is we have expressed in a 3, 4. Now here we have to report the result into 3 significant figures. So here first is a 5.61 because 7 is the greater than 5, and therefore and round off we have to. So before reporting result up to the significant value, we have to rounding off the principal must be applied in each case. Therefore correct answer is 5.61 in first case. In second case 32.4. In third 1.79 into 10 to the power 3. In case of 4 it is a 0.00784, and in case of 5 here 5000, so we can express it into 5.00 into 10 to the power 3, and number 6 decimal equivalent to 1/60, so it is reported after dividing we get 0.0167. So 167, 3 significant figures are there. So in this way we can express the result. How many significant figures are in each of the following number? Here we have to find out number of significant figures. So in this case 3, in this case also 3, in case of this is a 0.42, so in this case there are 2, and in this case, in the case of 4, there are 3, and only are there. Okay, so in this way the number of significant figures are there. Write the following in exponential notation. So these are the examples are given, and we have to write the in a scientific or exponential notation. So this number can be written in this way. Here is 1. So 13.256 into 10 to the power 3. This number can be written in this way, 5.00 into 10 to the power 4. And this can be written 5.340 into 10 to the power 4. And this is written in this way, that 1.0 into 10 to the minus 3. So in a scientific notation we can express the number. Now another example is that how many significant figures present in each of the following measured quantity, and what is the uncertainty indicated by the number given. So in this case, first is there a package of candy has mass of 103.42, and therefore here and second is the mass of milliliter of gas is 0.003 gram. Third is volume of solution is 0.2500 liter. So in case of first, a package of candy has mass of 103.42. In this case, counting from first non-zero digit in 103.42 to the last digit expressed, there are 5 significant figures. Therefore, the uncertainty is plus minus 0.01. In case of second, none of the 0 is 0.003 are significant. They shown only the location of the decimal point. There is only one significant digit, and uncertainty is plus minus 0.001 gram. And in case of third, the 0.2 is the first non-zero digit, and in 0.2500 liter, and so there are 4 significant digits, including the last 2 0. The uncertainty is here plus minus 0.0001. So in this way we can calculate number of significant figures in the given number. So today we have seen what is significant figures and what are the different rules to find out the number of significant figures in the given result or in the given measurement, and important rules are there related to the 0, and after that the rule number 1, addition and subtraction, and rule number 2, multiplication and division. And so how to report the final result, that we have seen, and based on all these rules of significant figures we have seen different types of numerical problems to calculate the significant figures.